Welcome back. In the last video, we created a loss function and an optimizer for our multi-class classification model. And recall, the loss function measures how wrong our model's predictions are. And the optimizer updates our model parameters to try and reduce the loss. So that's what that does. And I also issued the challenge of doing a forward pass with model 4, which is the most recent model that we created. And did I just give you some code that wouldn't work? Did I do that on purpose? Maybe, maybe not. You'll never know. So if this did work, what are the raw outputs of our model? Let's get some raw outputs of our model. And if you recall, the raw outputs of a model are called Logits. So we got a runtime error. Expected all tensors to be on the same device. Oh, of course. Why did this come up? Well, because if we go next, model 4 dot parameters, and if we check device, what happens here? Oh, we need to bring this in. Our model is on the CUDA device, whereas our data is on the CPU still. Can we go X? Is our data a tensor? Can we check the device parameter of that? I think we can. I might be proven wrong here. Oh, it's on the CPU. Of course we're getting a runtime error. Did you catch that one? If you did, well done. So let's see what happens. But before we do a forward pass, how about we turn our model into a val mode to make some predictions with torch.inference mode. We'll make some predictions. We don't necessarily have to do this because it's just test, but it's a good habit. Oh, y preds equals, what do we get? Y preds, and maybe we'll just view the first 10. What do we get here? Oh my goodness, a whole bunch of numbers on a page. Is this the same format as our data or our test labels? Let's have a look. No, it's not. Okay, oh, we need Y blob test. Excuse me. I'm gonna make that mistake a fair few times here. So we need to get this into the format of this. How can we do that? Now, I want you to notice one thing as well, is that we have one value here per one value, except that this is actually 4 values. Now, why is that? We have 1, 2, 3, 4. Well, that is because we set the out features up here. Our model outputs 4 features per sample. So each sample right now has 4 numbers associated with it. And what are these called? These are the Logits. Now, what we have to do here, so let's just write this down. In order to evaluate and train and test our model, we need to convert our model's outputs which are Logits, to prediction probabilities, and then to prediction labels. So we've done this before, but for binary classification. So we have to go from Logits to pred probs to pred labels. All right, I think we can do this. So we've got some Logits here. Now, how do we convert these Logits to prediction probabilities? Well, we use an activation function. And if we go back to our architecture, what's our output activation here? For a binary classification, we use sigmoid. But for multi-class classification, this is the 2 main differences between multi-class classification and binary classification. One uses softmax, one uses cross entropy. And it's going to take a little bit of practice to know this off by heart. It took me a while, but that's why we have nice tables like this, and that's why we write a lot of code together. So we're going to use the softmax function here to convert our Logits, our model's raw outputs, which is this here, to prediction probabilities. And let's see that. So convert our model's Logit outputs to prediction probabilities. So let's create Y pred probs. So I like to call prediction probabilities pred probs for short. So torch.softmax, and then we go Y Logits, and we want it across the first dimension. So let's have a look. If we print Y Logits, we'll get the first 5 values there. And then look at the conversion here. Y Logits, or Y pred probs. That's what we want to compare. Pred probs 5. Let's check this out. Oh, what did we get wrong here? Y Logits. Do we have Y Logits? Oh no. We should change this to Y Logits because really that's the raw output of our model here. Y Logits, let's rerun that. Check that. We know that these are different to these, but we ideally want these to be in the same format as these, our test labels. These are our model's predictions. And now we should be able to convert. There we go. Okay, beautiful. What's happening here? Let's just get out of this. And we will add a few code cells here so we have some space. Now, if you wanted to find out what's happening with torch.softmax, what could you do? We could go torch softmax, see what's happening. Softmax. Okay, so here's the function that's happening. We replicated some nonlinear activation functions before. So if you wanted to replicate this, what could you do? Well, if in doubt, code it out. You could code this out. You've got the tools to do so. We've got softmax to some x input, takes the exponential of x, so torch exponential over the sum of torch exponential of x. So I think you could code that out if you wanted to, but let's for now just stick with what we've got. We've got some logits here, and we've got some softmax, some logits that have been passed through the softmax function. So that's what's happened here. We've passed our logits as the input here, and it's gone through this activation function. These are prediction probabilities. And you might be like, Daniel, these are still just numbers on a page. But you'll also notice that none of them are negative. Okay, and there's another little tidbit about what's going on here. If we sum one of them up, let's get the first one. Will this work? And if we go torch.sum, what happens? Oh, they all sum up to 1. So that's one of the effects of the softmax function. And then if we go torch.max of ypredprobs, so this is a prediction probability. For multi-class, you'll find that for this particular sample here, the 0th sample, this is the maximum number. And so our model, what this is saying is our model is saying, this is the prediction probability, this is how much I think it is class 0. This number here, it's in order. This is how much I think it is class 1. This is how much I think it is class 2. This is how much I think it is class 3. And so we have one value for each of our 4 classes. A little bit confusing because it's 0th indexed. But the maximum value here is this index. And so how would we get the particular index value of whatever the maximum number is across these values? Well, we can take the argmax, and we get tensor 1. So for this particular sample, this one here, our model and these guesses or these predictions aren't very good. Why is that? Well, because our model is still just predicting with random numbers. We haven't trained it yet. So this is just random output here, basically. But for now, the premise still remains that our model thinks that for this sample, using random numbers, it thinks that index 1 is the right class, or class number 1. For this particular sample. And then for this next one, what's the maximum number here? I think it would be the 0th index. And the same for the next one. What's the maximum number here? Well, it would be the 0th index as well. But of course, these numbers are going to change once we've trained our model. So how do we get the maximum index value of all of these? So this is where we can go convert our model's prediction probabilities to prediction labels. So let's do that. We can go ypreds equals torch.argmax on ypredprobs, and if we go across the first dimension as well. So now let's have a look at ypreds. Do we have prediction labels in the same format as our yblob test? Beautiful, yes we do. Although many of them are wrong, as you can see. Ideally they would line up with each other, but because our model is predicting or making predictions with random numbers, so our model hasn't been trained, all of these are basically random outputs. So hopefully once we train our model, it's going to line up, the values of the predictions are going to line up with the values of the test labels. But that is how we go from our model's raw outputs to prediction probabilities, to prediction labels for a multi-class classification problem. So let's just add the steps here. Logits, raw output of the model. Pred probs, to get the prediction probabilities, use torch.softmax, or the softmax activation function. Pred labels, take the argmax of the prediction probabilities. So we're going to see this in action later on when we evaluate our model, but I feel like now that we know how to go from logits to prediction probabilities to pred labels, we can write a training loop. So let's set that up. 8.5, create a training loop and testing loop for a multi-class PyTorch model. This is so exciting. I'll see you in the next video. Let's build our first training and testing loop for a multi-class PyTorch model. And I'll give you a little hint. It's quite similar to the training and testing loops we've built before, so you might want to give it a shot. I think you can. Otherwise, we'll do it together in the next video.